Welcome to this video that discusses image recognition basics in Java. After watching this video, you will be able to define image recognition, identify key image recognition concepts, and explain the steps to create code for a simple image recognition system. Do you know about the technology that enables computers to see visual information from the world around them, like humans? This fascinating technology is called image recognition. When you look at a photo, you can easily recognize your friend's face or a cat. Image recognition aims to give computers similar capabilities. It teaches computers to identify and understand objects, people, places, and actions in digital images. Before learning about the code for image recognition, let's look at key image recognition concepts such as digital images, image processing, feature extraction, and classification. Let's begin with digital images. In computing, images are represented as a grid of tiny colored squares called pixels. Each pixel has a specific color value, typically represented by RGB or red, green, and blue values. For example, a bright red pixel might have an RGB value of 25500. Image processing involves manipulating an image to prepare it for analysis. Some of these commonly used operations include resizing images to standardized dimensions, converting color images to grayscale, adjusting brightness and contrast, removing noise or unwanted elements. What is feature extraction? Features are distinctive aspects of an image that help in recognition. These could be edges, corners, textures, or color patterns. Extracting these features helps the computer focus on the important parts of an image. Classification is the final step where the program decides what's in the image based on its extracted features. Classification might involve determining if an image contains a cat, identifying a person, or recognizing text. Let's implement an example of a basic image recognition system. This system will identify whether or not an image contains a cat. For this example, use the Deep Learning 4J library, a popular deep learning library for Java. Begin by adding the necessary dependencies to the project. Take a moment to view the code for this displayed on the screen. Next, download the pre-trained models for image recognition from repositories such as Deep Learning, 4J's Model Zoo, TensorFlow Hub, and convert to DL4J format, and model repositories on GitHub. For the cat recognition example, search for cat classifier model, DL4J, or similar terms. Now, let's create a simple program that loads a pre-trained model and uses it to identify cats in images. Take a moment to view the code for this displayed on the screen. Let's review the details of the process followed to create the image recognition example. The process entailed loading the model, image loading, pre-processing, converting to IND array, normalization, prediction, and result interpretation. For loading the model, a pre-trained model that has already learned to recognize cats was loaded, providing the program with the information it needed. The image was read from a file into a buffered image object, which is Java's way of representing images in memory. For pre-processing, the image was resized to 64 by 64 pixels because that's what the model expects. This was like standardizing the input. The image was transformed into a numerical format, an IND array, for the model to process. This represented the image as a 3D array of numbers, with one for each RGB color channel. For normalization, the pixel values were scaled from their original range of 0 to 255 to a range between 0 and 1, which helps the model process the data more effectively. To predict, the processed image was passed through the model, which returned probability values indicating the likelihood of the image containing a cat. To interpret the result, the probability was checked to see if it exceeded 0.5, which is essentially 50%. This helps determine if the image contains a cat. Take a moment to view the rest of the code displayed on the screen. In this video, you learned that image recognition enables computers to see visual information from the world around us, like humans can. In computing, digital images are represented as a grid of tiny colored squares called pixels, each with a specific color value, typically represented by RGB. Image processing involves manipulating an image to prepare it for analysis and includes resizing images to standardized dimensions, converting color images to grayscale, adjusting brightness and contrast, and removing noise or unwanted elements. An image's features, such as its edges, corners, textures, or color patterns, can be extracted to help the computer focus on the important parts. During classification, the program decides the image's contents based on its extracted features. The process followed to create a basic image recognition system entails loading the model, image loading, pre-processing, converting to IND array, normalization, prediction, and result interpretation.